Fala pessoal, tudo bem com vocês? Essa daqui vai ser então a nossa segunda temporada das entrevistas aqui no LCE. E hoje, para começar essa entrevista, eu vou conversar com um professor lá do Colorado, do School of Mines, o professor Michael Kaufman. Ele é um professor da área de Engenharia de Materiais. E nesse momento eu vou deixar aqui também para vocês o currículo vitae dele, então vocês podem acessar, ver toda a produção dele, tudo que ele já fez na vida dele. Vou deixar o link da universidade que vocês podem acessar. Nesse momento eu vou acabar trocando então para falar inglês com ele. Vou pedir para você ligar a legenda para você poder estar assistindo e conferindo a entrevista na íntegra. Professor, thank you for accepting this interview. It's an honor, and I guess it's really important to show people what we are and what we do, just demystifying the words researcher and scientist. So thank you for coming here.
You're welcome. Look forward to the conversation.
So my first question is about, as soon as people know you through your CV, who is Michael Kaufman? Where are you from exactly? How everything begins? Just a little bit.
Well, I grew up in a really small town, and the school didn't have a lot to offer, but I did take chemistry and math and things, and I really enjoyed some of the science things, and my mother always wanted me to go into engineering, so I had an opportunity to go to the University of Illinois, and I got involved in metallurgical engineering because of my chemistry teacher at the school I was in. He had actually just gotten a opportunity to offer like very low value scholarships to go into this department because they were trying to enhance the number of people they were bringing in. And I knew nothing about metallurgical engineering at the time, but I decided to give it a shot. I wanted to go into engineering, and I knew I could always switch into something else if I didn't like it. But I loved it, so I ended up staying in it. So I went through the University of Illinois. I don't know if you want me to keep going, but I worked as I went up through the school, through the years. I started working for a faculty member in the department doing die casting type research. Got involved with some graduate students. I wasn't too excited about the project. He wanted me to continue for a master's. I decided to go out and work, and I went out for a year and worked in industry in an area of aerospace materials, advanced aerospace materials for a company that was associated with Pratt & Whitney aircraft. It was their corporate research center, and they decided to bring students in and have them do their PhDs while working in the lab, and they connected me at the University of Connecticut to go to graduate school. And I started there, but one of the faculty from Illinois also came to United Technologies Research Center at the same time. I got to know him quite well. He was in the metallurgical department, and he decided to go back to Illinois, and I decided to go back with him. So I did my PhD with him. I was married. I had a child. I had a second child. We had a second child as I went back and start my PhD, so I was in a big hurry to finish. I thought I could finish in 2 years, which was unrealistic, but I finished in about 3.5 years, which was a pretty quick. I didn't do a master's, it wasn't required.
Oh, okay.
And I just went straight through and did the PhD. That's how I got started, and then I moved around a fair amount after that.
For me, it's the same. I also grew up in a small town, and my first contact with science was in a chemical class. Professor showed us on a video, and then I saw that, and I thought, okay, I'm going to work with materials, properties, but I didn't know that materials engineering would be the course that I studied at. So I stood for almost 1.5 years to discover that this specific course will do what I do now.
Yeah. We had, at the time, they had most of the courses in your first year or two at Illinois are all kind of similar for all engineers, but they had one introductory course with a very senior professor from the metallurgy department, and I just really enjoyed what the field looked like at the time, and got pretty excited about the opportunity. So
when I came here, when I got enrolled at UFSCar, I talked to Zepon, and he showed me the lab that we work with hydrogen, and he said, I have 2 options for you, hydrogen or work with steels and something. And I had been already visit the lab, and he asked me that, and I told him, oh no, I would like to work with hydrogen. So it's quite interesting. And this kind of influence at the beginning of the course, I guess it's so important for us. Having a good professor, a good mentor, it changes your path.
Yeah, no question. I would agree 100%. There were certain, had I had different experience with some of the other faculty that I wasn't as excited about, then I might have gone a different path. But I really, the overall experience was great.
I know you are a senior professor, and you've been through many kind of problems, and as an engineer also. And I will ask you your opinion about what is the toughest challenge we are facing as a materials engineer. An engineer, what do you think?
Yeah, I mean that's a tough question. I think society faces a lot of challenges, right? I mean, I think as an engineer, driven to do science, there was a lot of times we didn't worry about the larger context of what the research would impact. It was more about publishing papers and graduating students and training people. I think we're seeing necessarily so that we have to be looking at things, I would say, in context. What is it, if we're going to solve the climate challenges that we face, it's going to require a lot of engineering to do that. And in my opinion, I think, materials is only a small part of that, but some of the technologies that will have to be developed will clearly involve technology involving materials. I mean, you're working in hydrogen, as you mentioned, hydrogen storage. I mean, that's one aspect of addressing some of the challenges, but there are many, and it's worrisome especially for young people like yourself. I mean, I think keeping in mind that we used to just work on like alloy development. You don't worry about where the cobalt comes from. You don't worry about where the titanium comes from, and now we're starting to look at what is the source of this, and how is it being produced, and is it being produced in a way that is not harmful to the local environment, to the people in that environment, etc. So I think there's a lot more engineering and context that I see in the future, and I just think that we have to be more broad-minded about the environment as we look at the challenges we face.
That's interesting, because usually when we use to produce some samples, we might have some problems and this changes the elements, and then we have to redo this sample. Yeah. But we lost the materials, and we don't even necessarily know where they came from and how was produced, the impact of this production. So
more and more important these days, I think. And we never worried about it. It was about how much does it cost, and instead of how was it produced and who produced it, and what impact did that have on the environment locally, because there's a lot of huge challenges in some countries.
It's something that I'm starting a little bit to be a kind of mentor with some undergrad students, and it's something I remember when I was an undergrad student, teaching these kind of sources, this small knowledge is also important because we must deal with during all this path as a master's student, PhD, and if you don't start doing this in the beginning of the journey, we might be lost.
Yeah, and I would say the beauty is, as I see young people coming into the school at the School of Mines, that is front and center of most of their interest. Is I want to do something that's going to help the climate challenges we face, whether it's in materials or other areas. So I think I would say it's maybe not universal with all students, but it's significant that's a part of their focus, and I think that's fantastic to see, because that wasn't the case when I was starting.
I imagine. I have a question about the cooperation between you and our department, because we always listen like, there's this professor from this university, we have a collaboration, but no one ever tell us how he ever started and when and why did it have started. So could you tell us a little bit about that?
Sure. So my connection with Brazil, I never had any connection with Brazil until I went to the University of Florida. And then Andre Costa e Silva, who is quite well known in the thermocalc world, and he had contacted me when I was a fairly junior faculty at Florida, asking about doing a PhD, and he came and did a PhD with me early 90s. And then when he came back, after he finished, one of his colleagues that had co-authored a book with him, Paulo May from Unicamp, reached out and asked to come with his wife to do sabbatical. She was in polymer science, he was in metals. So they came in, mid 90s. And then the connection with UFSCar came with Claudio Chiminami. He'd followed Paulo a couple years later with his wife to come and do sabbaticals with myself for Claudio and with another faculty for his wife, Ruth. So they came, and then once Claudio went back after the year he spent in Florida, then there was sort of a steady connection of students that Claudio had sent. Some are now faculty. In fact, quite a few are faculty around different universities in Brazil. I started making fairly regular trips to Brazil at that time. We had exchange programs with some of the different agencies. I think CNPq here and National Science Foundation in the U.S. And that led to, I ended up coming in 2013 to do a sabbatical, so I spent 9 months here.
Wow.
Taught some classes, worked a lot with students and with faculty, and then I've come several times for congresses, I guess as you call them, and then we continue to have a number of students either come to do their PhDs, come for sandwich programs for 6 months, for 3 months. It's a pretty steady stream. At any time there might be one or two what I don't think I had. I went from University of Florida to University of North Texas and then to Colorado School of Mines. I don't think I had any at Texas, but I had quite a few in Florida, and I've had a pretty steady stream, including Francisco Corey, who's a faculty here, who did his PhD there. The second student that came after Claudio to Florida was Marcelo Falcao from USP, and he's now been sending quite a few students as well, and one of them just finished their PhD and is still working there as a postdoc. So we just had this steady connection over the years. Claudio's visited quite a few times, Bautis visited, Bolferini's visited, so quite a few faculty have come to visit me wherever I've been and work with their students and so on.
So that's so nice because listen to that, because it's a story we no one tells about, and to ask a professor, a faculty from here, how many professors do you know abroad, and how was that about, and when did that started? So talking to you explaining that is so amazing, and now noticing that we have so many professors and so many faculties that have been there, and so interesting. It's so amazing.
No, it's been a great collaboration. We've published a lot of papers together. We've had a really great experience working together.
About work specifically, could you tell us a little bit about your current research area or something?
So I'm very passionate about materials development and really understanding sort of structure-property relationships. So that's always been my focus. I'm more agnostic when it comes to actual systems, as opposed to really understanding the ability to manipulate microstructure either through liquid-solid processing, solid-solid processing, all the different things you can do. And really understanding that, and then using advanced characterization tools to help with that process. So that's always been my passion. I started in 2011. I started in the U.S. at School of Mines, what we call the Center for Advanced Non-Ferrous Structural Alloys, and that's a consortium of companies that pay annual membership fees to participate, and the projects tend to be selected by the companies and voted on by the companies, and then the funding that is available will fund students to work on projects that are ranked highest among the different projects that are put forward. And the nice thing about that is they're projects that the industry's interested in, as opposed to what I as an academic might be interested in. That started in 2011, so we're in year number 12, I think, and it's what the National Science Foundation created. They created what they call an Industry University Cooperative Research Center program. They created this back in 1984, and it's they consider it one of their more successful programs in the engineering world, just because they put a little bit of money in, and then they look at the leverage of money that the companies provide. And then they track where the students go that are part of these programs, and I think the latest numbers I've heard is about 35% of the students that work in these different IUCRCs around the country end up going to work for the sponsor companies. So it's a pipeline for students to go to these companies that are participating in these centers. So that's a real value for the student, but it's also value for the companies. And I would say this student experience is a little different than the typical student experience, because a lot of times, students work with a single faculty member and on a project, and they're kind of narrowly focused. Here, the students are being evaluated not only by their faculty, but also by all the company mentors. So they develop these relationships. So there's a lot of professional development as well as academic development, and I think they're a lot of work, but I think for the student experience, it's better than a lot of the other projects that I've worked on in the past that have been more PI focused.
It's something I would like to do, for example, but have a good relationship with companies, and I know that's something complicated and it changes from countries to countries, but here I know we have some project as well, and it's something that I would like to do, maybe during my PhD. It's a kind of experience we don't have exactly during the undergrad course, but I could have done something like an internship, but I couldn't because of due to the COVID. But
No, we've had some of the IUCRCs have international companies that join, but they also have some countries have seen the value of the program and have actually tried to emulate it in their countries. So there are some universities in other countries that actually have teamed up with U.S. universities, and we've talked to some other universities, but that's never quite made it over the finish line. But we have had Embraer here in Brazil was actually a member of our consortium maybe 6 or 7 years ago.
Do you have anything, any work or kind of research you would like to highlight here to tell us a little bit about that interesting?
I mean, again, as I said earlier, I'm a bit agnostic in terms of the material systems, but there has been this work that there's a lot of work going on here in high entropy alloys and using them and trying to investigate this sort of multi-component space. And we've done some some of the early work was done at School of Mines in that area, and we continue to work on that. But it's good to see that some of the work we've done with people at UFSCar has actually led to that work kind of continuing here. So there's a lot of collaborations back and forth with the people here, which has been fantastic. So
that's amazing, and I'm supposed to tell you that it's something I really like it. I really enjoy to work with multi-component alloys, and something that beginning as an undergrad student and now as a PhD, I don't know, but it's something that I understand what's happening. It's quite interesting, and it's something that no one knows, like steels or any other kind of alloys.
Yeah, it opened up a lot of, certainly a lot of opportunities, I would say, a lot of composition spaces that we've never really investigated before. So so we'll see where it ends up. But I was quite impressed with seeing some of the hydrogen work that your group is doing with Zapone and so on. He's tried to explain some of that to me, and it's pretty fascinating.
Yes. I have something that someone might be interested in, like how can any student apply to be your mentor or go to Colorado? Or
I mean, there's different ways. Obviously, a lot of students have come through some of the agencies that you have through these sandwich programs. I gave a couple of seminars, one here at UFSCar, one at USP last week, and I showed a slide saying, please apply. So, if somebody wants to come as a graduate student, we have, sort of an annual recruitment process for doing that. It's best if they reach out to faculty, but there is a portal for just applying, but that's not necessarily the best way. But if you've got any connections if the students have any connections through faculty with people at our institution, that's obviously a better way to get, to make those contacts as saying, I'm interested in coming to Colorado School of Mines to work on a PhD or a master, because the system's very different. Yeah. The system there, faculty write grants. Unlike here, their grants include research dollars for supporting students. So if a student wants to come, it's usually up to the faculty to have resources to support that student through their whole time with pursuing their degree. So that's, if they can make those contacts, we have a lot of active faculty working on a lot of different very interesting things. So, if a student's looking at the website and they say, okay, I'm interested in a few areas, making contacts with the people and trying to express their interest, and then they can help them go through the application process to get their foot in the door, so to speak.
Yeah, that's important, because for us here is a little bit different.
It's quite different.
And to apply, we must send some information to the programs, and I might have or not a scholarship, and I might change the scholarship, so it's quite different.
Yeah, and we do have a memorandum of understanding with UFSCar currently, so there are ways that we can even potentially share courses or share students and things like that. We haven't pursued that a lot per se, but certainly that's a possibility as well.
Yes, it's something that I wanted to ask you, because actually not necessarily everybody knows that, so it's interesting to students, undergrad or graduate students, to look for that and go forward. So if you want to do that, so just look the website. I will let in the description. And for our last question, as I asked you earlier, and I said, what advice would you give yourself if you were a young researcher?
Yeah, that's always a tough question, because hindsight's always 20/20. But I think for me, and what I always try to get students to understand, I mean, there's so much information available to students now, which is great. But I think the more successful ones are going to really sort of dig pretty deep and really try to get that really foundational understanding, because a lot of the tools that are available can give you great data, but if you don't really understand what is driving those tools, or really understand fundamentally, you can't ask the right questions about, does this really make sense? Because sometimes you'll get answers that don't make any sense. And I think just getting that, make sure you're getting that foundational understanding. Read some of the old textbooks, because back in the day when people didn't have all the information, they had to really think a lot about things. And so I think that's one thing. I think asking questions, networking is so critical in everything that we do. Relationships, collaborations, all these things I think help, because there's a lot of people doing a lot of great things. It's hard to stay current. So, but don't isolate yourself. Work well with other people. I'm actually really impressed with what I see here with the collaborations between faculty and with the student, and how well they seem to work together, because nobody's an island, and the more you try to isolate yourself, I think you're doing yourself a disservice. So just being I think collaborative, working well, there's a lot of great minds out there that we can learn from, and vice versa.
Oh, thank you. Actually, as I said to you earlier, it is kind of personal question, because I am a young researcher, and I'm willing to be a professor one day, maybe. So it's interesting to listen to that, not just about the professional things, because it's something that is life, actually. Living as a researcher, you are taught that. Life taught you these kind of things, and sharing this is kind of an honor to listen and to grab this kind of advices.
Yeah, and I mean, people talk a lot about failure leading to success. I mean, you're going to make mistakes, and just that has to be part of the process, and that's okay.
So, Professor, really thank you for participating in this interview for our first episode in this second season. I'm going now to change Portuguese to Finnish to tell people. But, pessoal, muito obrigado por você chegou até aqui. Não esquece de curtir o vídeo, assinar o canal e você pode colaborar com o canal de qualquer forma que você quiser. Não esquece também de visitar o perfil do professor lá no CV, você pode acessar novamente, né, o site da Universidade, do School of Mines, dá uma olhada lá em todos os processos, nas áreas que você possa ter interesse, e aí você pode, como o professor falou, entrar em contato. Existem diversas formas que você pode estar tendo uma colaboração com o pessoal de lá. Muito obrigado e até mais. Thank you, professor.
Thank you. Appreciate it.